Hey there, and welcome. Have you ever looked at a bright red toy or maybe a deep blue car part and just wondered, how did it get that perfect, lasting color? Well, today, we're going to pull back the curtain on the hidden science of pigments, those tiny, tiny particles that give our entire plastic world its vibrant hues. You know, every single color you see in the plastic objects all around you, it starts out as a fine dust, a lot like these amazing powders right here. But how does it get from a bowl into, say, your water bottle or your phone case? The answer is a very special ingredient, and it's the hero of our story today, the pigment. So, what is a pigment, really? Well, the key thing to remember is that it's not a dye. See, a dye dissolves into a liquid, but a pigment, it's a fine powder made of solid particles that absolutely do not dissolve. They're just suspended in a material like plastic, scattering light and giving the object its color. A great way to think about it is like adding sand to water, not sugar. Okay, so here's what we've got on tap. First, we're going to meet the two main families of pigments. Then we'll pit them against each other in a performance showdown. We'll also tackle the super critical question of safety. And finally, we'll see how manufacturers have to perform this complex balancing act to choose just the right color for the right job. All right, first up, let's meet the main players in the world of color. You'll see that all pigments pretty much fall into two major categories, and each one has its own unique personality and, its own set of skills. So on one side, we have organic pigments. These are complex carbon-based molecules. And on the other side, we have inorganic pigments, which are usually simpler mineral compounds, things like metal oxides. They are fundamentally different from the ground up. And those differences? They have huge implications for everything from how vibrant a color is to how well it holds up under the sun. Now let's really see how these two families stack up against each other. It's time for the showdown. We're going to break down all the key differences between them, from their color and vibrancy to their strength and everything in between. Okay, so if you want that bright, brilliant, in-your-face color, you're looking at organic pigments. They offer a massive spectrum of shades and have a really high tinting strength, which just means a little bit goes a very long way. You can think of them as the sprinters of the color world, super fast and flashy. In contrast, inorganic pigments are a bit more subdued, with a narrower range of earthier, darker tones. But here's the trade-off, right? While organic pigments might win the beauty contest, the inorganic pigments are the undisputed marathon runners. They are incredibly durable. I mean, their resistance to heat, light, and weather is excellent, mainly because they're basically stable minerals. The organic pigments, well, their performance varies wildly. Some are tough, for sure, but a lot of them just can't handle the heat or they'll fade under the sun. Now let's look at their actual physical differences. Organic pigments have these small, low-density particles, and that's what makes them transparent. This is awesome for things like candy wrappers, where you want to see through the color. Inorganic pigments, on the other hand, have larger, denser particles, giving them high hiding power, or what we call opacity. This is perfect when you need a solid, non-see-through color, like for a car bumper. Okay, we need to shift gears and talk about something incredibly important that goes way beyond just performance, and that is safety, because the chemical makeup of these pigments can have some really serious health implications. This is the question every single manufacturer has to answer. Can you use these beautiful, durable colors without putting people at risk? For a long time, the answer to that was, well, it was complicated. And here's why. A lot of those super stable, really durable inorganic pigments, like the classic bright yellows and deep reds, were historically made with heavy metals. We're talking about lead, cadmium, and chromium. These are compounds that are known to be toxic and harmful to both human health and the environment. This was really the dark side of durable color. But, and this is a huge but, the world has changed. Today, the use of these substances is strictly controlled by this whole web of international regulations. Standards like the FDA in the US, RoHS in Europe, and others all around the globe set really tight limits on heavy metals. And this isn't just paperwork. These regulations require serious, rigorous testing to make sure that any pigments used in consumer goods, food packaging, and especially toys are safe long before they ever reach a store shelf. So, given everything we've just learned, brilliance versus durability, transparency versus opacity, and of course the critical importance of safety, how does a company actually choose a pigment? It's a really fascinating balancing act. It's not just a simple choice between organic and inorganic. Pigments are actually graded into performance tiers. Low-performance pigments, they're totally fine for items with a short life, like a disposable shopping bag. Mid-performance offers a good balance for things like packaging or pipes. But for a car part that has to endure sun and heat for years and years, you're going to need a high-performance pigment with exceptional durability, and you're going to be willing to pay for it. So you can break down the whole decision-making process into 4 key steps. First, what is the product? A kid's toy has completely different needs from an outdoor pipe. Second, what does it need to put up with? Intense heat, constant sunlight? Third, and this is non-negotiable, does it meet all the safety standards? And finally, does the cost actually fit the product's value? So really, every colored plastic object you see is the result of a very complex decision. It's a carefully calculated trade-off. The manufacturer has weighed that brilliant pop of an organic pigment against the steadfast durability of an inorganic one, all while navigating those essential guardrails of safety and cost. So the next time you pick up a colorful object, take a closer look. That color is not an accident. It's a choice. It's a piece of applied science, balancing beauty, strength, and safety right there in the palm of your hand. Now that you know the story behind the color, what will you see differently?